Welcome to all. Myself A. Venkat Subbareddy, Assistant Professor of Electronics and Communication Engineering Department, and I am dealing with my basic electronics engineering course. So in this session, I will discuss about semiconductor physics. So introduction to semiconductor physics, atomic structure. So atomic structure refers to the structure of atom comprising of nucleus which contains protons and neutrons. This is the structure of atom. So in the center it has the nucleus, and this nucleus contains neutrons and protons, and these are the orbits. So in these orbits you have the electrons. So the negatively charged particles are called as electrons, and they revolve around the center of the nucleus. Protons are the positively charged, and neutrons are neutral, and electrons are negatively charged. So the atomic weight of any atom, so it is considered as a sum of number of protons and number of neutrons. Atomic number is number of protons divided by number of electrons. So this is basic structure of any atom. So it contains nucleus, protons and neutrons, and electrons which are revolving around the nucleus. Then electrons are the tiny particle, and they are negatively charged, and they have the negligible mass. So the charge of electron is 1.6 into 10 power minus 19. Mass of electron is equal to 9 into 10 power minus 31 kg. So this is the orbital structure of an atom. So at the center it is having the nucleus. It contains the neutrons and the protons. In the orbits it has electrons. So whenever if you are moving away from the nucleus, the energy levels goes on increasing. So the outermost orbit have the electrons which have the highest energy compared with the first orbit. So whenever the electron is jumping from higher orbit to the lower orbit, it normally emits light in the form of a photon. So which is equal to delta E is equal to h into v. H is the Planck's constant, v is the velocity. Then energy bands. The energy bands are group of energy levels for electrons in the same orbit. The electrons in the same orbit exhibit different energy levels. The grouping of these different energy levels is known as the energy band. So there are three different types of energy band. One is called it as an valency band, second is conduction band, third is forbidden band. And this is the band structure. So one by one we will see valency band. So the electrons which are available in the outermost orbit are known as valency electrons, and the band containing these valency electrons is known as valency band. That is, the outermost orbit contains the electrons, those are called as an valency electrons. This is the highest energy level occupied by electrons, and this energy band, it is never empty, either it will be partially filled or completely filled. So this is the structure of valency electron. So the outermost orbit have the two electrons. So these are the two valency electrons, and these two valency electrons are available in the valency band. And this outermost orbit, it has either completely filled or completely stabilized, or there are some empty levels. Then second is conduction band. So this band contains the conduction electrons. That is, this band contains free electrons, and these are the unfilled lowest energy level. Whenever the electron becomes free, it will enter into the conduction band from valency band. It may be partially filled or empty, but it never completely filled. Forbidden band. The separation between conduction and valency band is known as forbidden band. This gap is equal to energy required to make valency electron free. There is no chance of electrons in the valency band. So remember this. There is no chance of electron in this band. It is the separation between conduction and the valency band. So based on these three energy bands, materials are classified into three types based on the electrical conductivity. One is conductor, another is insulator, and the third one is semiconductor. The conductor. It is a material that easily conducts electrical current. It contains more number of free electrons. It has large number of free electrons which are loosely bounded to the atoms or the nucleus. So these loosely bound valence electrons, they can easily break away, they can come out of their atoms and they will become free and they will carry the electricity. So this is the band structure. In this case, both the valency band and this conduction band both are overlap. In this case, the forbidden energy gap, that is Eg is equal to 0 electron volts. So the forbidden gap does not exist in the conductors. So the number of free electrons are of the order of 10 power 28 concentration per centimeter cube. Conductivity, it is in the range of 0.5 ohm centimeter. The examples are copper, gold, silver, aluminum. All these are comes under the conductors. Then second type of material is insulator. It is a material that does not conduct electrical current under normal condition. It has no free electrons, and this is the energy band diagram. So the conduction band and this valency band both are separated by a large band gap, so which is approximately equal to 5 electron volts. So in the insulator, the separation between conduction and the valency band is more. So whenever any valency electron, if it moves to conduction band, it requires large amount of energy to be supplied for these valency electrons. So the valency electrons, they are tightly bound to the atom. So that's why it requires more energy to become free from the atom. So the forbidden energy gap is greater than 5 electron volts. For ideal cases, conductivity of insulator is 0, which means the resistivity is infinite. For example, paper, rubber, glass, etc. all these are the insulators. Next, third category is semiconductor. Semiconductor are the materials that possesses the property of electrical conductivity which is less than the conductors, or in between insulator and the conductor. A semiconductor in its pure state is neither a good conductor nor a good isolator. So this is the band structure. The valency band and this conduction band both are separated by a small energy gap, which is approximately equal to 1 electron volt or less than 1 electron volt. It has very few free electrons. Forbidden energy gap is very small, which is approximately 1 electron volt. Generally, silicon, germanium, arsenic, these are the some semiconductor materials. This is the comparison between three types of materials. Forbidden energy gap, which is not exist, both the conduction and the valency band are overlap, so the energy gap is 0. And in the semiconductor it is small, and in the insulator it is larger. Resistivity, conductors are good, they will allow the electric current, so the resistivity is low, and semiconductor it is moderate, for insulator it is very high. So the flow of current, so that is the current carrying charge carriers are, in the case of conductors, the carrying charge carriers are free electrons, and in the semiconductor the charge carriers are electrons and holes, but in the insulator it is almost negligible. Charge carriers in conduction band, it is completely filled, it is partially filled. Insulator it is completely vacant. Charge carriers in valency band, they are almost vacant. Semiconductor is partially filled and the insulator is completely filled, because all the valency electrons are there in the valency band only for the insulator. Example, copper, aluminum, graphite. Semiconductors are silicon, germanium. Insulators are paper, rubber, glass. Applications, conducting wires, transformers in electrical cars are used for conductors. Semiconductors are diode, transistors, optocouplers. Insulators, sports equipment, home appliances. Then we discuss specifically about semiconductor materials. So semiconductors are the group of materials having conductivity between those metals are conductors and insulators. So you can see the periodic table. The third group elements, boron, aluminum, gallium and indium. Fourth group elements, carbon, silicon and germanium. Fifth group elements, phosphorus, arsenic and antimony. So there are two general classification of semiconductors which are made up of either same group or a different group. The first one is elemental semiconductors. These are the semiconductors, they are formed by using only fourth group elements like this. So silicon and germanium, these are the two semiconductors, they are made up of using fourth group elements. Then second type is compound semiconductors. They are formed from special combination of group of third and the fifth group elements. So like this, aluminum phosphide, aluminum arsenide, gallium phosphide, gallium arsenide, indium phosphide. So these are the materials, that is the fourth group elements are combined with the third group elements or the fifth group elements. Then they are called it as an compound semiconductors. So in the silicon and germanium, silicon is most preferably used in the manufacturing of integrated circuits because of its availability. So the silicon, it is having the atomic number 14. So in the first orbit, so the 14, so we can write down it as an 1s2, 2s2, 2p6, 3s2 and 3p2. So the first orbit you have the 2 electrons, and second orbit you have total 8 electrons, 1 2 3 5 6 7 8, and in the third orbit you have the 4 electrons. So for the silicon, the atomic number is 14. So the first orbit contains 2, second orbit contains 8 electrons, and the third orbit contains 4 electrons. Similarly, germanium, the atomic number is 32. The first orbit contains 2, second orbit contains 8 electrons, third orbit contains 18, and the fourth orbit contains 4 electrons. And this is the lattice structure of silicon. So silicon contains 4 valency electrons, and these 4 valency electrons, they will form covalent band with the neighboring 4 silicon atoms. And these electron pairs will form one covalent band. So this is called as an covalent band. It contains one electron pair. And all these electrons, they are tightly bound these in the covalent band. So the valency electrons in germanium are in the fourth cell, that is, this is the fourth orbit. But for silicon, they are in the third cell closer to the nucleus. So this means that germanium valency electrons are at higher energy levels than silicon. So the germanium has the valency electrons in the fourth orbit, and for silicon it is in the third orbit. So the fourth orbit has the higher energy levels compared with the third orbit, and it requires a small amount of energy to escape from the atoms. This makes germanium is more unstable at high temperatures. So these semiconductor materials are formed either by using two elements like gallium arsenide or gallium phosphide, or you may use the three element, either aluminum, gallium and arsenide. So you can form these semiconductors either two or three elements. Thank you.